Hi, my name is Vladimir Horikov, and this is the CQRS in Practice course. In this module, we will take a look at the sample project. I will guide you through its codebase, and we will talk about its purpose and the underlying problem domain. The application we'll be working on is the API for a student management system. Here is the domain model of this system. This is the main class of our model, student. It consists of a name, email, collection of enrollments, and a collection of disenrollment comments. We'll get back to this one in a moment. A student can have up to 2 enrollments in courses. Each enrollment has a grade, either A, B, C, D, or F. The courses themselves have a name and the number of credits students receive for them. Whenever the user deletes an enrollment, he or she must specify the reason why the student wants to discontinue taking this course. This is what the disenrollment class is for. It shows which course was discontinued, the date and time of when this happened, and the comment from the student. All fields are mandatory. It means that when you create an enrollment, you must specify the student's grade. And when you delete one, you have to type in the comment from the student. The database pretty much mimics this domain model. I'll show it to you shortly. The API exposes the standard CRUD operations, the standard create, read, update, and delete. Here you can see a user interface that works with our API. Note that this UI is for visualization purposes only. It's easier to follow the changes in an API project when you see how they affect the user interface. We will not be dealing with the code of the UI in this course, only with the API underneath it. Also note that although it's a desktop application, it could very well be a web one, written in JavaScript. It works with API parsing and sending JSON messages, just like a regular web application would. I've chosen a desktop UI because I personally have more experience with them than with web ones. Alright, so you can see here a list of students with a single student Alice. The list also shows the students' names, emails, and the courses they are enrolled in. Students can be enrolled in only 2 courses, and so they are displayed here right away, in separate columns. Those columns contain the name of the course, the grade the student received, and the number of credits this enrollment provided. Note that the grade is taken from the enrollment database table, whereas the number of credits comes from the course table. So this is the read operation. The application provides the create, update, and delete operations too. Let me show them to you. When we create a student, we need to specify a name and an email. Let it be Bob and bob@outlook.com. And we can also indicate the student's enrollments. Although these fields are optional, we could leave them empty. So let's say that Bob has chosen literature and received an A for it. And let's also say that he's chosen trigonometry as his second course and had a B for it. Saving this, and you can see the new student has appeared in the list. Now, as the student exists, we can update it. For example, we can change the enrollment from literature to calculus, the grade, and if I reopen it, you can see that the change is persisted successfully. We can also delete the enrollment. To do that, we need to select the empty option from the list of courses. When we do that, the application tells us to provide a disenrollment comment, and this comment is mandatory. If I try to save the form without it, the API returns an error, and the UI displays it in this message box. Don't want to take this class anymore, and click OK. And you can see that Bob now has only 1 course. Calculus has been removed from his list of enrollments. Note that although we deleted the first course, the UI shows the empty slot in the second one. That's because from our system's perspective, there is no difference in the order in which the student enrolls in the courses. And so the course that was the second one becomes the first after we remove the enrollment. The field for the course grade shows up automatically when I try to create a new enrollment. And it's mandatory too. If I try to save the form without it, the API also returns an error. Alright, along with all these features, the API exposes some pretty sophisticated search functionality in here. We can ask it to return only students who are enrolled in a specific course, and we can also request students who are enrolled in a particular number of courses. For example, I can choose calculus, and the application shows that only Alice is enrolled in it. If I select microeconomics, no one is in here. And if I ask for students who are enrolled in exactly one course, you can see that the UI shows us Bob. And if I select 2, it's Alice, just as we would expect. Finally, we can delete a student. Here I can select Bob and click Delete. Alright, let's now look at the code. The source code for this course is available on GitHub. You can use this short link to access it. By the moment you see this course, there would be 2 folders in the source code repository, before and after. You can follow our discussion throughout this course and refactor the application with me. To do that, just navigate to the solution in the before folder. It contains the application in the state you will see shortly. Alright, so here it is, our codebase. You can see here 3 projects: API, Logic, and UI. The API is an ASP.NET Core application that targets .NET Core 2.1. Logic also targets .NET Core 2.1. And because the UI is a desktop application written in WPF, it targets the full framework. In this folder, you can find the script that will create the database schema and data required for our sample application. Here's the content of the API project and the Logic one. Let's look at the domain model first. This is the course class. Pretty straightforward, as you can see, just the name and the number of credits. Its mapping is straightforward too. I'm using NHibernate here as the ORM and Fluent NHibernate to work with NHibernate mappings in a fluent manner. And here's our main domain class, student. It consists of name and email. It also has a collection of enrollments. Each enrollment represents a link between a student and the course, with some grade. The grade is an enum that can be either A, B, C, D, or F. Aside from constructors, there is also an update method that updates the course the student is enrolled in and the grade. By the way, the pattern you see here is a good way to work with collections in domain classes. The IList field is what the ORM maps to when loading enrollments from the database, but instead of exposing this collection as is, you make it private and create a wrapper property around it with the type iReadOnlyList, which shows the client code that it cannot modify this collection and have to use separate methods for that. Because there can be only 2 enrollments per student, there are 2 helper properties in here: first enrollment and second enrollment. They use this getEnrollment method in order to return the appropriate enrollment. If there is no enrollment with such an index, the method returns null. Note that despite this invariant for having maximum of 2 enrollments per student, the product owner stated that this limit could be increased at some point in the future. Hence this collection of enrollments, and not just 2 properties here and in the database. We don't want to put ourselves in a difficult position by denormalizing the database prematurely, because it would be hard to add more enrollments in this case. Alright, there's also a collection of disenrollments here. These are, as you remember, for the comments the student provides when they disenroll from the course. Here's its content: the student, the course, the date and time, and the comment itself. Back to the student. Here you can see 2 constructors, one for the ORM, which is non-public, and the other one for the client code, which shows that in order to create a student, it needs to provide a name and an email. Note that in a real-world application, you would want to validate these 2 strings, and probably even wrap them into value objects. I'm omitting these for brevity. Along with the above properties, we also have 3 public methods. Remove enrollments deletes an enrollment from the student. Add disenrollment comment is for adding a comment when the student disenrolls, and enroll is for creating an enrollment. Note this check here. If the number of enrollments is already 2 or more, we throw an exception. This way, we ensure that the domain model maintains its invariance and always resides in a valid state. Here is the mapping for the student entity: ID, 2 properties, and 2 collections. ReSharper tells me that this is unnecessary. Okay. This part of the mapping tells nHibernate to map directly to the backing field. The inverse setting, that the side of the relationship is not the one that determines the value of the student ID column in the student database table, and cascade all delete orphan, that nHibernate needs to delete all enrollments and disenrollments from the database when we delete them from these collections. Okay, let's now review the API project. The base controller class contains some helper methods for us to use in other controllers. For example, we can call OK with some resulting object, and this method will wrap it into an envelope before passing to the client. The envelope is a class that helps keep the structure of all responses from the server consistent. You can see that, along with the result itself, it contains the error message, if any, and the time this response was generated. The non-generic version of envelope contains some useful helper methods. And here's the student controller, which contains the actual application functionality. It accepts a unit of work, which is a wrapper on top of nHibernate session and transaction, and creates two repositories. The getList method is what returns the students to display in the data grid on the UI. It accepts two filter parameters, the name of the course the student is enrolled in and the total number of courses. Here's the repository method that does the actual filtration. We first form an iQueryable that represents a SQL query nHibernate will generate for the database. If the course name is specified, we build up this query by adding a where clause to it. After that, we force nHibernate to execute it and give us the resulting list of students. And then, if the second filter is set, we return only students who have this exact number of courses. Alright, so after the repository returns us all those domain objects, we convert them into DTOs, data transfer objects, and return to the client. The DTO looks like this. It contains an ID, name, email of the student, and it also contains the information about his two courses. The create method creates a student. It accepts this same DTO back. It treats the name and the email from it and uses them to instantiate a student. If the first course name and its grade is set up, the API finds this course and enrolls the student to it. Note that here we are parsing the incoming grade, which is string, into the enum, and we do the same for the second course enrollment. After that, we save the student, commit the transaction, and return OK to the client. The delete method is pretty straightforward too. It finds the student by the ID and deletes it. The main complexity lies in the update method. Here we also find the student, update their name and email, and then start the synchronization process. We first determine whether there are differences between the incoming DTO and the existing first enrollment. For that, we're using this private method, hasEnrollmentChanged. If the incoming enrollment course name is empty and the existing enrollment is empty too, we consider this as no change. If one of them is empty and the second one is not, or if the course name or grade differ, it means the user has updated the enrollment. So after we ensure that there is indeed a change to this enrollment, we need to decide which one is that. If the incoming course name is empty, that means the student disenrolls, and we need to check that the disenrollment comment is provided. If so, we remove the enrollment from the student and add a disenrollment comment. Next, if the incoming course is not empty, it means one of two things. Either the student enrolls in a new course or updates an existing enrollment. In either case, we need to make sure that the grade is provided. After that, we get the course from the database by its name and check to see if the existing enrollment is null. If it is, it means that the student enrolls. If not, that they update the existing enrollment. And let me actually inline this variable. There is no need to have a separate one here. And we do the same procedure for the second enrollment. Let me inline the variable here too. Okay. After the synchronization is done, we commit the transaction and return success to the caller. Alright, that's it for the application functionality. Let's glance over the rest of the code real quick. You saw the student DTO already. It contains all the fields required to display a student in the grid and update it when posting the changes back to the server. Exception handler is an infrastructure class that catches all unhandled exceptions and converts them into 500 responses. And here's the startup class. And let me scroll down so that you can see there is nothing else in this class. Session Factory is a class that we use to generate and hibernate sessions. There should be only one such class in the application, hence we add it as a singleton. Unit of work is a wrapper on top of sessions themselves and should be instantiated and disposed of on each web request. This addScoped method does exactly that. It creates a unit of work, and because this class implements the iDisposable interface, ASP.NET disposes of it after the request is completed. And here's the underlying database. It pretty much mimics the domain model. The student table consists of the ID, name and email. Enrollment references the student and the course, and it also has a grade which is represented as integer. Disenrollment, all the same fields as in the domain model, and the course. Alright, that's it for the application codebase. Let's now talk about its drawbacks. I'm sure you have worked on applications a lot in the past, so much that you might not even realize that there is something wrong with this codebase. So what is it? As we discussed in the first module, CQRS brings us three benefits: scalability, performance, and simplicity. Scalability is something we will talk about later in this course, and it's not obvious that this application suffers from scalability issues anyway, so let's skip it for now. What about performance? Well, let's open the student repository once again. This is the method that filters the existing students by courses they are enrolled in, and the total number of such courses. What can you tell about its performance? Up to this moment, this method operates upon an iQueryable, which is good because all link statements made upon an iQueryable object translate into the corresponding SQL. It means that this where statement, this filtration, is done in the database itself, which is exactly what we want. But here we force the ORM to fetch all the students with this course into memory, and only after that continue narrowing them down. It means that the database will send us an excessive amount of data, which we then filter manually in the memory. This is a suboptimal solution, and can hit the performance quite badly. It's not noticeable in our sample application, of course, but that's because there are just a few students in our database. In a real-world project with hundreds of thousands or even millions of records, it would. Ideally, you should transfer only the minimum amount of data between the server and its database. But why are we doing that? Why force the ORM to fetch all data from the database on this step? It's because we wouldn't be able to do this filtration otherwise. Neither Hibernate nor Entity Framework support filtering by the number of elements in a one-to-many relationship, and so the only possible solution here is to finish up this filtration in the memory, using the in-memory link provider. Another performance problem which comes up quite often is the problem called N+1. It's when the ORM first fetches the students and then for each of them performs a separate call to retrieve their enrollments, and then another one to get each of the corresponding courses. So instead of just one database round trip, you end up with several of them, and the more students there are, the more round trips you will have. In most cases, you can overcome this problem by instructing the ORM to include the navigation properties into the SQL script and fetch them along with the main object, but it's not always possible. And it's very easy to overlook this issue when relying on the ORM to query the database. Alright, and what about the code complexity? Is our code well structured and easy to understand? Not really. Look at the update method once again. The fact that it is so long and that there are deep indentations is a sign that something is not right. And indeed, we're trying to do too many things here. Look at the section starting from this if statement. If there is no first course in the incoming student DTO, we disenroll the student from it. Otherwise, we either try to enroll the student in or modify the enrollment. And the same for the second course. We could probably simplify this code by removing the duplication between the first and the second courses, but still, Even with only a single such if statement, there is still too much going on here. This method clearly violates the single responsibility principle, one of the solid principles from Bob Martin. Another hint that tells us about the violation is this student DTO. It is a jack of all trades. It's used for both sending the data to the client and receiving it back when updating the student. And because of that, some of the fields here remain unused in certain scenarios. For example, when updating the student, the user needs to only specify either grade or a disenrollment comment, but not both. And there is no need to fill out the credits fields because we don't update them on the server. They are used for displaying information on the UI only. This is a very crowded approach, and it's not the best way to organize the application code. What we're doing here is we essentially merge all the possible modifications to the students into a single giant update method, whereas each of those modifications should have their own representation. This artificial merge of responsibilities entails increase of complexity, which in turn damages the code-base maintainability. This is especially painful in long-running projects, where complexity tends to pile up over time and at some point becomes so immense that the whole application moves to the category of legacy applications. It's still valuable for the business, but no one dares to touch it, as every modification is likely to introduce new defects. It's important not to allow such a growth of complexity, and domain-driven design in general, and CQRS in particular, are very good at it. We will start untangling our codebase in the next module. This thinking in terms of create, read, update, and delete operations is called CRUD-based thinking, and it often goes together with anemic domain model. Anemic domain model is when you have domain classes that contain data and services classes that contain operations upon this data. But this is not always the case, and it's certainly not the case in our situation. In fact, our domain model is organized quite well and mostly encapsulated. If you look at the student entity, you can see that both collections are hidden from the client code so that it's impossible to modify them. The collections the clients of this class see are both read-only and don't have a setter. The parameterless constructor is hidden. We expose a nice rich constructor instead that accepts both name and email, which explicitly tells the client code that these two pieces of data are required in order to create a new student. And we also have public methods that check for invariant violations. For example, before enrolling the student in a new course, this method validates the number of existing enrollments. We do have public setters in the name and email properties, but that's only because I have skipped the validation of this data for brevity. And because there is no validation needed, it's okay to keep these setters public. In a real-world application, you would probably want to wrap these properties into value objects. The only issue with regards to encapsulation is in these two methods. Because they are always used together, you always need to add a disenrollment comment when you remove an enrollment. It would make sense to merge these two methods into a single one. But this issue is easy to fix. Other than that, the encapsulation here is pretty solid. Our domain model is not anemic. If you want to learn more about anemic domain models and how to transform them into rich and highly encapsulated ones, check out my course about refactoring from anemic domain model towards a rich one. In this module, you saw the initial version of the application we'll be working on throughout this course. The two major drawbacks with it are the use of the single model for both reads and writes, and the CRUD-based thinking. The first issue leads to inability to optimize the database queries. You saw that we had to fetch an excessive amount of data from the database because the ORM doesn't support the kind of querying we need. It's also easy to fall into the N+1 problem, where you end up with multiple round trips to the database instead of just one. The second issue leads to a necessary increase of complexity. Because the application tries to fit all operations into the narrow box of create, read, update, and delete operations, what we end up with is the merging of all student modifications into a single giant update method. Another way to look at this problem is view it as the violation of the single responsibility principle, CRP for short. The update method does too many things at once, which is never a good thing. In the next module, we will start refactoring away from CRUD-based interface towards task-based interface. You will see how it simplifies the code base and helps improve the user experience.